So there's a good possibility that you'll find multiplying and dividing fractions easier than adding and subtracting them for this reason. They don't have to have common denominators. So if we were going to do 3/4 times 2/3, the way we set up this problem is actually to say 3 times 2, which are these numbers here, multiplied by, or over, sorry, not multiplied by, over 4 times 3. So, and in this case, all we have to do is multiply each side. So 3 times 2 is 6. 4 times 3 is 12. So we've done that multiplication. Can we leave our answer in that form? No, it has to be reduced. So will 6 go into 12? Yes, it absolutely will, and it goes in one time. So we can reduce the 6 over 12 fraction to 1/2, and we have just multiplied 3/4 by 2/3. Okay, so let's do another one. Let's do 3/16 times 4/32. Okay, so our setup here is 3 times 4 over 16 times 32. What does that equal? Okay, so we will multiply our top terms first, which is 12. 3 times 4 is 12. 16 times 32, can't really do that off the top of my head, so let's reach over here and we'll just do some math on the side. This is where in the real world you might use a calculator. Don't want you to use one here because I do want you to be able to do this by hand, and I don't believe you're permitted a calculator in your certification exam. So let's go ahead and just do this out by hand so that you can follow and keep up with that in case you don't get a calculator. So we can do 32, we can do times 16, and the way we start working this is 6 times 2 is 12, 6 times 3 is 18, and then plus our 1 is 19. We add a 0, and then 1 times 32 is 32, and then we add. So we have 2, we have 11, so that's 5/12. So we have 12 over 5/12. Now we need to determine if we can reduce this or not. We know that this can be reduced, and the reason we know that it can be reduced is because it's an even number. And since even numbers are always divisible by 2, anytime we see an even number on the top and the bottom, we can immediately know that we can reduce it to some extent. Now, you know from when we did the reductions, there is an element of this being sort of a trial and error process, but since 2 is what we know will help us reduce this fraction, even if we have some extra steps in the process, let's just go ahead and do this the way we could. This will always give you the right answer even if you have extra steps. So 12 divided by 2 and 5/12 divided by 2. 12 divided by 2 is 6. 5/12 divided by 2 we would probably have to do out. So 5/12 divided by 2. Does 2 go into 5? Yes, goes in 4 times. Does 2 go into 11? Yes, goes in 5 times. Does 2 go into 12? Yes, 6 times. Okay, so with that in mind now, what we can do is rewrite our fraction here. We had 12 divided by 2 was 6, and 5/12 divided by 2 was 256. Okay, we obviously know once again that this can be reduced further because we still have even numbers on both sides. So let's keep going. 6 divided by 2, 256 divided by 2. So 6 divided by 2 is 3. That one's easy. And if we do 256 divided by 2, does 2 go into 2? Yes, sure does. And in fact, I should probably use a different color here so that you can, I got a bunch of numbers floating on the screen that may not be very helpful here. Okay, so we're going to do 256 divided by 2. Does 2 go into 2? Yes, goes in one time. leaves us with 0. Does 2 go into 5? Yes, goes in, whoops, doesn't go in 4 times. Goes in 2 times and makes 4. Okay, and that leaves us with 1. Drop our 6. Does 2 go into 16? Yes, it goes in 8 times. So then we have 3 over 128. Is that a properly reduced fraction? Yes, it is. We cannot bring that down to any lower terms than we have, and the numerator is less than the denominator. So we have a good answer there. All right, let's look at one division problem here. Pretty similar to multiplication, but not identical. We'll take a look at that now. So the interesting thing about dividing fractions is that it's actually a multiplication problem. So if you were given a problem of 2 over 3 divided by 6 over 7, you're actually still going to do this as a multiplication problem, but to make it a multiplication problem, you're going to invert that or flip it. So what you're going to be left with is you will leave your 2 over 3 the same, just like it is, and then you will flip your 6 and your 7, invert them, so that you have now 7 over 6 instead of 6 over 7. And that inversion that we did right here changes our divided by sign to a multiplication sign, and then we just can go straight from there. So 2 times 7 is 14, 3 times 6 is 18. And can we leave our answer like this? Of course, no, we can't, because they are both divisible, again, by at least 2. So let's go ahead again and do that out. So we had 14. If we do 14 divided by 2, we're left with 7. If we do 18 divided by 2, we have 9. Is that a proper answer? Yes, it is. It is a proper answer. Numerator is less than a denominator, and it's fully reduced. So in this inversion, making 6/7 and turning it into 7/6, and then flipping our sign to multiply, we are able to do a division problem like that.